Hey, hello and welcome everyone. So this video is all about elasticity. And I'm going to talk about price elasticity of demand, price elasticity of supply, income elasticity, cross-price elasticity. And I'm going to make the link between the definition of elasticity, the formula, and then the interpretation. But I'm going to do this without a numerical example. And stay with me on this. The reason why is I'm going to provide the foundation behind those formulas that typically gets lost, so that when you see a numeric example, it's not just plugging in numbers and getting a value that you don't know what it is. I'm going to teach you here how to explain or how to interpret what that value is. This video is sort of like a counterpart or a follow-up to my supply and demand model explained, or it's like all about a supply and demand, or whatever I called it, where I go into depth in terms of the aspects of supply and demand that typically get lost when we're first learning it. Well, something like that's my goal here. Now, if you have an example you want to see or want to look at my other videos, I've got numerical examples, type in the comments, leave a comment. It helps the algorithm, I guess. It helps people find and then learn economics from me. So that's good to do. You could say what you had for breakfast, or you could say why you're studying economics, or you just say hi, or you could just not. So whatever. But my goal here is I want to think about going from the definitions of elasticity to the formula and then interpreting it. So that's what we'll do here. So for price elasticity of demand, price elasticity of supply, income elasticity, and cross-price elasticity. So the first thing is like, what's the point? Like, why do we even have elasticity in the first place? So when prices change, we know there's going to be a change in quantity. If we're talking about demand, if prices rise, we'll get a lower quantity demanded. If prices fall, we'll get a higher quantity demanded. And that actually has nothing to do with elasticity. That's just the law of demand. And then for supply, if prices rise, well, there's a larger quantity supplied. If prices fall, there's a smaller quantity supplied. Again, has nothing to do with elasticity. That's just the law of supply. What elasticity is giving us is a way to talk about how quantity is reacting to the change in price. We're interested in comparing the proportional change in quantity to the proportional change in price, right? The arrow of causation is we're having a change in price that's therefore causing a change in quantity. And we're looking to see how much the quantity responds, be it quantity demanded, in the case of three of our elasticities, price elasticity of demand, income elasticity, and then cross-price elasticity, or be it the price elasticity of supply. So we're interested in like how much is quantity responding. Elastic means very responsive. Inelastic means not very responsive. And we kind of want to keep this in the background. Elasticity is just all about responsiveness. Is there a big reaction to a change in price, or is there a small reaction? So price elasticity of demand, that's just the percentage change in quantity demanded for a given percentage change in price. I'll come back to that. Price elasticity of supply is the percentage change in quantity supplied for a given percentage change in price. Income elasticity of demand is just the percentage change in quantity demanded for a given percentage change in income. And then cross-price elasticity of demand is comparing a price change in one good to the quantity change in some related good. So it's the percentage change in the quantity demanded of some good A for a given percentage change in price of some good B, right? So we'll talk about price elasticity of demand. There's the definition. Price elasticity of supply. There's the definition, or income elasticity, and then cross-price elasticity of demand. And the reason why I've got these like right here in front of us is you want to look at the relationship between how these things are defined, right? We're always interested in like the percentage change in quantity given the change in one of these other variables. And since you can look between these four definitions, and really all I did is apart from like price elasticity of supply, where it's like quantity supplied, but really all that I did is I just copy pasted and I took out like the change in price and I replaced that with change in income. And I took out, like, I added change in quantity of some good A for percentage change in some good B. But the definitions are really the same underlying phenomenon, which is like we're interested in the percentage change of one thing and the effect this has in terms of the percentage change of the other thing that we care about, which is almost always the quantity demanded. Could be quantity supplied. And just as these, like, conceptual definitions are really closely related, so are the formulas, and I'll talk about that a little bit later on. First, I want to go into depth on price elasticity of demand, and then thinking about how to interpret that formula, right? So looking just at the price elasticity of demand, if we're literally interpreting price elasticity, right? Price elasticity of demand is the percentage change in quantity demanded for a given percentage change in price, right? So we'll use this epsilon to stand for elasticity, right? So the elasticity is the percentage, this delta is change, right? Percentage change in quantity divided by the percentage change in price. It's a fraction, it's a ratio, right? It's the percentage change in quantity demanded for a given percentage change in price. And we'll compute this. We'll have some values. You might just have percentages, and then you'll compute the value just dividing one by the other. Or you might have a point, and then you have to use midpoint formula or point elasticity formula. I'll talk about that in a second. But either way, you're getting a percentage change in quantity, dividing it by a percentage change in price. And you're going to end up with a value, a unitless value, that's going to be interpreted as the elasticity. Now, for price elasticity of demand, because the demand curve is downward sloping, price elasticity of demand is always negative. But sometimes we report the absolute value of the price elasticity of demand. Because we know the price elasticity of demand, because downward sloping demand, we're always going to have a negative price elasticity of demand. Sometimes, because it can get kind of confusing to talk about, is like -3 bigger, smaller than -1/2, right? Well, it's more elastic. It's more responsive. We'll see this in a second. Sometimes it's easier to talk about that in absolute value. Compare 3 to like 1/2, right? +3 to +1/2. So the only thing is you have to be consistent. If we're talking about like just the pure elasticity, it should be negative. If we're talking about absolute value, it should be positive. All right, so I'm going to talk about absolute values here, even though I dropped like those upright bars that indicate absolute value. I'm just going to talk about absolute value here. So how to interpret elasticity values as elastic or inelastic? Well, if the computed value of elasticity is greater than 1 in absolute value, we say it's elastic. If it's less than 1 in absolute value, we say it's inelastic. All right, so like, why? Why does that make sense? Well, the way to think about this is from the fact that elasticity is a formula based around a fraction, right? So start thinking about the fraction. Think about, firstly, like how do you get like bigger and bigger fractions? Well, like one recipe for a larger fraction is a larger numerator, right? How do you get smaller and smaller fractions? Smaller and smaller fractions are associated with a larger denominator. Okay, so the denominator and the numerator in our fraction here has a special important like meaning tied to the economics that we're discussing here. So the numerator is the percentage change in quantity demanded. The denominator is the percentage change in price, right? Sorry, numerator is always the top of the fraction. Denominator is the bottom of the fraction, right? So the numerator, that's the quantity portion, and then the variable that's changing. So if it's price elasticity of demand, it'll come through the denominator. If it's income elasticity, same thing, coming through the denominator. It's always the quantity demanded in the numerator. Anyway, so if we have an inelastic demand, here we're looking for a situation where the computed value is going to be less than 1 in absolute value. Well, how do you get a fraction less than 1? So you're thinking about fractions like 1/2, 1/3, 1/4, right? So these are all situations where the denominator is larger than the numerator, right? Well, here this has an interpretation. A larger denominator means a larger percentage change in price and a smaller percentage change in quantity. Right, this is going to be smaller than 1 in absolute value. And that's exactly the recipe for like really unresponsive quantity demanded, right? Here we have like a large change in price. Price changed a lot, but quantity didn't change very much. This gives us a fraction that's smaller than 1. That's why if we have a computed elasticity that's smaller than 1 in absolute value, we'd say that the demand is inelastic, right? Well, what about elastic? Now we've got the opposite. Right? We have a small price change, but we've got a large quantity changed. And this is going to give us a fraction that's larger than 1. This is where the numerator has the bigger effect than the denominator, right? So now we're thinking about fractions like 2/1 or 3/1 or 4/1, right? Those are fractions, and those are ways to kind of think of like extreme fractions where it's very obvious that the numerator is bigger than the denominator, right? And if the numerator, if the top is bigger than the denominator, that means we've got a larger percentage change in quantity than the percentage change in price. So we change price by a little and quantity changes by a great deal. That's very responsive demand, right? And so we'll call that elastic. This is if the fraction's larger than 1 in absolute value. Now, in order to actually use these formulas, in order to make the intuition like come to life, we've got to break this out of the percentage change in quantity, percentage change in price, and come up with a way to do a numeric example. So to actually calculate the elasticity, we have two main algebraic versions and a calculus version. So in my in my principles of economics class, I really like teaching the point elasticity formula and an intermediate. A lot of other people like teaching the midpoint formula, so I'll sometimes teach that as well because that's what a lot of other classes do. And then students that go on to other classes are prepared based on like what is the expected knowledge coming out at the lower level. But actually, I think the point elasticity formula is probably the better formula, but I'll kind of talk about how it works. So point elasticity, right? It's, for instance, we have 2 points. We have point 1 and point 2. We have Q1 and P1, Q2 and P2, right? So these are like 2 points on a demand curve. And the way that this works is we'll take the second quantity, usually the new quantity, minus the old quantity. That's a change, right? New minus old is going to give us the change. And then if we divide it by the original, that's what makes it a percentage change. We'll do this for quantity and we'll do this for price. So the formula could be like here I've got like Q1 minus Q2 or Q2 minus Q1 divided by Q1. So here's the change in quantity divided by the original quantity, gives us the percentage change. Here's the change in price divided by the original price, that gives us the percentage change in price. Or you could think of this as like new minus old divided by old, and do that for quantity and for price. So that's the point elasticity formula. The reason why it's called point elasticity and the reason why I like it is because then you're computing the elasticity literally at like exactly the point Q1, P1, right? So Q on the horizontal, P on the vertical is going to be like 1 point on your demand curve, and you're computing the elasticity at that point. If you use the midpoint formula, what that's actually doing is it's taking your new point and your old point, or old point and new point, however it works, and halfway in between is where you're getting that elasticity. So the way that the midpoint formula works is you take your new minus old, or Q2 minus Q1, and you just divide it by the average quantity. And then you take your new price minus old price, or P2 minus P1, and divide it by the average price. The way the formula, like to make the average price was that, like sometimes you might have seen the midpoint formula somewhere or like in a textbook or whatever. And so to compute the average, it's actually like Q1 plus Q2 divided by 2. And so like it's just a whole bunch of fractions. It's like Q2 minus Q1, and then average Q is actually like itself a fraction. Q1 plus Q2 divided by 2, and that just gets confused. And so like, but then you have a bunch of Q2s and Q1s and 2s and things flying around. So I want you to think of it as just one quantity minus the other quantity divided by their average, because that's all you're doing. And then one price minus the other price divided by their average, because that's all you're doing. And then you're dividing the change in quantity divided the change in price. Right? The calculus version looks scary, like if you haven't had calculus or if you don't kind of remember it, but basically it's just like the slope of the demand curve. This is like one, it looks like 4 things. It's like dq, dp, p, and then q. It's actually like, if you're actually computing this, you need 3 numbers. This is a slope, dq, dp is the rate of change in quantity with respect to price. And then here is the price and here's the quantity at which you're computing the elasticity. Right, so that's all this is doing. So you just need a point and then a slope. That's why sometimes we call, like, it doesn't have to be calculus. It's really just literally multiplying slope by the point. So sometimes I like to say that you could think of elasticity as the slope at a point, which is a little bit kind of non-technical, but the idea is you're multiplying the slope of the line by that particular point, and then that get the ratio of the price and quantity in that point, and that gives you the elasticity. Anyway, so these are our 3 formulas, and then these are borne out across the different types of elasticities, right? All right, so we have the exact same formulas for price elasticity of supply. The only difference is elasticity is always negative for demand. Sometimes we take the absolute value. For supply, it'll always be positive. So actually, like, I don't need to redo these formulas to give you, this is for price elasticity of demand. I don't need to redo these formulas to give you price elasticity of supply. It's the same thing. It's just that if you're calculating with 2 points on a demand curve, you're going to get a negative elasticity. If you're calculating with 2 points on a supply curve, you'll get a positive elasticity, right? Okay, so that's because demand curves are downward sloping, supply curves are upward sloping. But what is more interesting is thinking about the income elasticity. So here we're going to swap out price with income, just like we did in the verbal definition. Here with the mathematical definition, we're going to swap out prices with income. And so the point elasticity formula is just like change in quantity divided by original quantity, change in income divided by original income, and there's our income elasticity. The midpoint version is like change in quantity divided by the average quantity, change in income divided by the average income. In the calculus version, it's like dq di times I over q, right? Just swapping out I's and P's relative to the original formula. Now for income elasticity, you might wonder about the sign. Actually, the sign's really important for income elasticity. So if it's positive, we have a normal good. If it's negative, we have an inferior good. And then 0 would just be something that's invariant to income. So it's like, I don't know, like the quantity demanded of air, like to breathe, right? Probably invariant to income, right? So in order to get those signs, you want to think about what has to happen in terms of the change, right? So here I've got like minus over minus, plus over plus, plus over minus, minus over plus, and then 0 over something. So what I'm doing here is this minus means like, what's the sign for this change? So this would be like a bigger quantity minus a smaller quantity. Oh, that would be a plus, right? A bigger income minus a smaller income would be a plus, right? So if income rises, if quantity rises and income rises, oh, that's a normal good, right? Income rises and quantity rises, demand rises. What if income falls and quantity falls? Oh, that's a normal good. Yeah, that's exactly why this is doing that. What about an inferior good? This would be like a decrease in income, but the change in quantity is positive. So income has fallen, you've bought more. That's an inferior good. Or income rises and you buy less, right? That's an inferior good. And then 0 would be like a 0 change in quantity, like income does whatever, and the quantity doesn't change at all. That would be a 0 income elasticity. That'd be like if it's invariant to changes in income. Now the magnitude also matters, like the computed value of the elasticity, because that tells us like how income elastic it is, or how income inelastic it is. And so like how responsive to income. So if you have an income elasticity of like 1/2, that'd be it's positive, so it'd be a normal good, but it'd be relatively unresponsive to income, pretty income inelastic. But if you have an income elasticity of like 2, that's actually, so first off, that's still a normal good, and it's larger than 1, so it's pretty responsive. We would call the first one an income elasticity of 1/2, like a necessity, and an income elasticity of 2 would be a luxury. So if it's bigger than 1, we typically call it a normal good that's a luxury. If it's smaller than 1 but bigger than 0, we'd call it a normal good that's a necessity. Okay, so and then the last one that I'll talk about is cross-price elasticity, right? So for cross-price elasticity, we use the prices from one good, the quantities from another. So this is like the quantity demanded of good A, the new quantity demanded of good A minus the old quantity demanded of good A divided by the original quantity demanded for good A. Here's the new price of good B minus the old price of good B divided by the old price of good B, right? Q2 minus Q1 divided by Q1, P2 minus P1 divided by P1. And as scary as the cross-price elasticity sometimes looks, it's really just like the quantity changes from one good and the price changes from the other, right? That's all it is. And then again, midpoint or arc elasticity is just like the change in quantity divided by the average quantity, change in price divided by the average price. The calculus version, it's just dq dp p over q, and the difference again is like we're doing quantities for good A and prices for good B. That's all it is. And again, for cross-price of elasticity, or cross-price elasticity of demand, we care about the sign. The positive sign would indicate we've got substitute goods, right? So the price of one rises, and then we buy more of the other, right? That's exactly substitutes. Or the price of one falls, we buy less of the other, right? And so that's exactly substitutes relationship. The negative sign indicates complements. So this would be the price of one rises, you buy less of the other. Or the price of one falls, you buy more of the other, right? Again, the positive is just saying like, what's the sign of the change, right? So the change in the numerator is the change in quantity. In the denominator, it's a change in the price of the other good, right? So what's the direction of the change? Is it a positive change or is it a negative change? Is it a gain or a loss in terms of like new from old, right? And so if it's positive, that's what's necessary to get a positive cross-price elasticity. Negative gets us a positive cross-price elasticity. Or if the signs don't match, now you get a negative cross-price elasticity. We interpret that as complements. You always want to think of the economic intuition behind it, which is what I did before. So if price of one rises and you buy more of the other, that's substitute behavior. Price of one rises and you buy less of the other, that's complements behavior. And the magnitude matters. It governs the degree of responsiveness. So how elastic or how inelastic is the relationship between those goods. And so if it's really large, like if it's a positive 5, right, that would be very large and positive. So this would indicate that they're substitutes and they're pretty close substitutes. What if it was like 1/4 That's still positive. So they'd still be substitutes, but they're not very responsive. What if it's minus 1/3, right? Well, that'd be negative, so it tells us that they're complements, but because it's between 0 and -1, negative 1/3 is, we'd say, oh, it's pretty unresponsive. They're complements, but pretty relatively inelastic, relatively unresponsive. Or if it was like -6, right? That's complements because it's negative, and because it's further from 0 than -1, that's pretty responsive. That'd be a pretty high degree of cross price elasticity, right? It could be 0. If it's 0, those goods are completely unrelated. So you've got like the price of one good rose and the other one you saw no effect. And that happens as well. And these are the type of elasticities that firms would really care about, because you want to know how responsive is the demand of one of your products to another one of your product line, or to your rivals, or to changes in income, what happens during a recession, so on and so forth. All right, so I've reached the end of my notes here. Go ahead and conclude. I sure hope you enjoyed the video. And I realize now I skipped my puppy study break to the very end. So here's the puppy. Was waiting through the whole lecture for puppy study break, and now I guess you get a puppy study break before you go to your next task. But anyway, hope you enjoyed the video. I'll see you next time. I guess I need to wave or whatever in the camera. So.